My name is John Moore. I'm a professor of climate change at the University of Lapland and also chief scientist at the College of Global Change and Earth System Science in Beijing Normal University, where I lead the Chinese geoengineering research program. I spent a lot of time and effort visiting universities, research institutes, and actually explaining to people in China what it was, geoengineering, what it was about and what it was not about, because of course many people are immediately frightened by this concept of geoengineering, whereas the framing that I prefer is more of a conservation measure. It's about trying to preserve the system, the climate system, the Earth as it is. And then I think the Chinese community had a much more positive view on it. They could see it in the same kind of light as things like the thousands of years of experience China's had on managing the Chinese landscape through things like irrigation measures, through things like a planned approach to agriculture. And in a sense, China differs very much from the experience in the West, and particularly North America. The Chinese very densely populated landscape is managed much more like a garden than a kind of wilderness where man is separate from nature. In China, it's very much man and nature are an inseparable whole. So in that respect, geoengineering can be seen as an extension of this Chinese philosophical view of man and nature. China does have very ambitious goals, and I think at least reaching peak emissions is certainly doable simply by increasing the energy efficiency of industry, by removing a lot of the worst coal-fired power stations, and China's done a lot of that. Replacing it by renewables like wind and solar is becoming more and more important. So China is very, very keen on that. And I think also very, very critically, China has had a feeling of duty that it is the voice of the developing world. And most of the geoengineering research international has been focused on the European and the American very developed, high resource countries. There had been none in the developing world. So this setup in China is something that we consciously wanted to try to expand and to try to internationalize as much research as possible, to show that it isn't something that some scary Dr. Strangelove characters are trying to do in labs, behind military guards and things like that. Well, we were looking at the solar radiation management side, I think mainly because that is where most of the actual science is happening. And in fact, most of the controversy as well. Pretty much everybody agrees it would be great to reverse our emissions and remove the amount of CO2 in the atmosphere. That's absolutely the way to go. The problem is it takes a long time to do that. And if the climate system gets into a position where we're going to lose significant parts of it, like the West Antarctic ice sheet, or changes to the Atlantic overturning circulation, or losing the Amazon rainforest or something, we need to be able to do something quick, fast, and hopefully not disastrously dirty. And pretty much solar radiation management is the only tool that's in the box. There's a lot of ways of doing it. You can inject aerosols into the stratosphere, or you might be able to look at changing low-level clouds over the ocean to replace this dark ocean, which absorbs a lot of energy from the sun, with a more reflective cloud deck. And there are other possibilities as well. But this solar radiation management is something that is doable on fairly short timescales. Afforestation is a very big deal in China. they are something that has tremendous local benefits from this ecosystem services. It improves the quality of the landscape immeasurably on local scales. The problem with deforestation is that even if you covered the whole of the Sahara and the whole of Australia with trees, you'd only lower the greenhouse gas, the CO2 concentration in the atmosphere by about 30 parts per million, which is what, maybe 15 years of emissions. But if you're really talking about removing CO2 that's in the air right now, I think it's a big step. Those measures, as I understand it, don't actually exist at the moment. So people are relying on a lot of things that they are really betting the farm, literally they're betting the farm on a technology that doesn't actually exist right now. So if you want to have a plan B, in case we just simply have got to turn down the temperature, otherwise bad things happen, then really, you're looking at solar geoengineering. Towards the end of the project, we started to kind of really try to find piecemeal solutions to this kinds of impacts, and to say, okay, instead of just looking with a focus on the global climate, can we do things to preserve particular parts of the system, like the ice sheets, for example, or the permafrost? Can we somehow maintain these in a way that doesn't have some of the potential downsides if you were trying to cool the whole planet by injecting an aerosol layer into the stratosphere? I think it's really important, or very helpful, at least for me and for many people that I've spoken to try to break down this seemingly enormously, overwhelmingly complex problem of the climate. Let's break it down piecemeal and tackle things one step at a time. We've got this huge potential of pretty catastrophic sea level rise if West Antarctica collapses. So, can we do something about that ice sheet to keep it there, even if the temperature rises by 3 degrees, let's say? Can we do something to stabilize it? And I think the answer is yes, we can. And it can be done for reasonable amounts of money, and it can be done essentially with technologies that we have at the moment. So you could actually go to the source of the water, which is the ice sheet, and stabilize it, keep it in its present configuration. And that is a hell of a lot cheaper than dealing with hundreds of millions of people being forced to move. Targeted approaches whereby you're trying to tackle an impact at its source is probably a lot easier to deal with from the international governance situation, because, for example, the Arctic permafrost is held almost exclusively in 3 countries, mostly in Russia and Canada, and then Alaska, so the US. And they basically have 99% of the world's permafrost. So if you get those guys on board to how to deal with it, in a way, you don't need to worry about the other 180 countries around the world. You're just simplifying the problem tremendously. The Chinese project's governance groups have had a particular approach towards the Chinese government in particular. They want to try to fill in the Chinese government on the kinds of international relations implications for doing geoengineering, and what kinds of political approaches China should take towards it. The Chinese academic community, and I think the Chinese philosophy as a whole, tends to be really quite conservative. They don't want to be going against the general consensus. They would prefer to do things as an agreed set of responses. They take very, very seriously their commitments through treaties or international agreements. So I don't think they would suddenly unilaterally go about doing something that would change everybody's climate around the world. China tends to take a backseat almost. But I think when it comes to climate and potentially geoengineering, they can't really sit in the back. They have to be up there, front and center, because they play such a leading role in emissions, in population, and representing in some way the developing world. But all of that also means, I think, that they won't be doing it unilaterally. They will be trying to build some kind of a consensus. At least that's what I would hope that they would do.